So Unit 5 is about, we're going to focus on square roots, and then the new thing we're going to focus on is things called imaginary numbers. That doesn't mean that they're imaginary in the sense of like, fairy tales and stuff. That's just the word that the mathematicians who came up with it chose to give it. Okay, so we'll get there though. So for now, what our goal for a day is, we're going to review how to simplify square roots. Okay, we'll talk about what an imaginary number is, and then we'll look at simplifying square roots that have variables in them, and some of them will have this imaginary number stuff going on within them. So basically that's it. So square root, A is the square root of B if A times A equals B. So like for instance, let me write, instead of saying A and B, let me use 8 and 64. 8 is the square root of 64 if 8 times 8 is 64. Okay? So you guys know this one over here. What's this one? 3. It's 3, right? Now, I like to talk about square roots using a story about turtles. So I was watching a documentary one time, and it turns out that turtles' parents are not quite as loving as some parents are. What they do is they lay their eggs in the sand at the beach, and then the eggs hatch, and the parents are gone when they hatch. So those baby turtles are on their own from the very beginning, and then they have to scamper their way to the ocean, and most of them don't make it because seagulls and predators come along and pick them off. But a few make it, and that's their little life cycle they go through. So when I talk about, when I saw these square roots one day, I thought, hey, this is a lot like square root. This is how square roots kind of work. Let me show you what I mean. So what times what makes 9? 3 times 3, right? Okay. So here's how I like to talk about square roots. And you think, well, that's kind of stupid, Mr. Bailey, but it comes in helpful for other things like the one over there, and I'll show you in a minute. So here's how it works. When a mommy turtle and a daddy turtle love each other very much, they have a baby turtle that looks just like them, and he hatches, but the parents are gone. Okay? So that's the turtle story. So he comes out of the egg, and the parents take off. All right? So now you guys might think, that's stupid, Mr. Bailey. I know what the square root of 9 is. I don't need your turtle story. That's fine. I just like it for things like this one over here. 12 doesn't have a nice square root. By the way, when you do have a nice square root like this, that you get a normal number, these are what we call rational numbers. Okay? That thing over there, if you tried to find the square root of that, you would have to use a calculator, and it's going to be some weird, funky-looking decimal. And those are what we call irrational numbers. Okay? But we do have a way that we can simplify these things. So I'll show you how to do that. First of all, so by the way, I'm just going to call this irrational, and that's because it doesn't have a nice square root. Okay? Now, what times what makes 12?
3 times 4.
Okay. You could have also done 6 and 2. That would work also. But we'll go with 3 and 4 because it doesn't matter. And what times what makes 4? Okay, so I've got a 3, a 2, and a 2. I can't break those numbers down anymore because they're prime. Like 3, the only thing you could do 3 is 3 times 1, and that's pointless because now you've just got the 3 again and another 1, which doesn't do anything. So once you get to a prime, you're done. So we're going to write it like this. Do you guys see a mommy turtle and a daddy turtle? We do, right? So when a mommy turtle and a daddy turtle love each other very much, they have a baby turtle that looks just like them, and then they leave. Now this guy right here, he didn't have any mates, so no babies. He stays inside there. That's the answer. So whenever you're doing square roots that are not perfect, you take out the pairs that you can. But anything that doesn't have a pair stays inside. Okay, so that's how square roots work. Remember, a square root is what times itself gives you this number. Well, we don't have a normal number that times itself that gives you 12. That's not 322. It's 3 times 2 times 2. Yeah. And what I did was we took a 1, 2 out for the pair. All right, so that's square roots. Rational numbers means it's a nice normal number. Weird answers that don't have perfect square roots, those are irrational numbers. All right, so let's take a look at some algebraic examples. This is algebraic because we've got letters in there, but it really doesn't change the story all that much. So here we go. Let's start with number 1. We have 50x to the 4th. I'm sorry, 5th. Okay, so off to the side, I'm going to write the part that's under the square root. That part that's under the square root is called the radicand. So I'm going to write the radicand off to the side, and I'm going to break it up. Now, the first thing I'm going to do is I'm going to separate the number from the variable. Okay? And what I want to do is I want to break this thing apart by multiplication. So what times what makes 50? 5 times 10, I agree. And the 5 is already prime, so I'm going to circle that. That means that one's done. But let's do the 10. What times what makes 10? 2 and 5. Those are both prime, so I'm going to circle those. That means those branches are done. And then the x to the 5th, all that means is, and you don't really have to write this if you don't want to because it's kind of obvious, at least on this part. But all that means is you've got 5 x's that are being multiplied together. So when you have x to the 5th, that just means you have 5 x's. So what we're going to do is we're going to take all of these ends of the branches here, and we're going to stick them under the radical. So I've got a 5, I've got a 2, I've got a 5, and then I've got 5 x's. I'll share with you a shortcut in a second to where maybe you don't need to, but all right. So, do we see any mommy turtles and daddy turtles? We do. What's one of them? Yeah, so there's one pair of turtles. They can have a baby turtle, then they abandon their children. And then, do we see any other mommy and daddy turtles? Yeah, we've got quite a few here. Okay, so pairs. They have to match, right? Yeah, you can't have a turtle breeding with a lizard if they've got to be 2 turtles, right? So we've got x and x. That can make a baby. That can make a baby. But we have a couple of people that didn't find, or turtles that didn't find any mates there. So we've got a 2 that has no mate. We've got an x that has no mate. So now the question is, what do we do with this stuff on the outside? We just multiply it together. So what is x times 5? 5x squared. And on the inside, what do I have? 2x. And that's it. Now, why do we do this? Well, it helps us do a lot of things. It helps us with adding. It helps us with simplifying. But this is the irrational part. That's the part where we can't find a nice square root for it. And this is the rational part of it. That means that part of it did have a nice square root. So we're breaking it apart basically into its rational and irrational parts. And that's how we simplify them. So step 1, break it apart, right? Step 2, do the turtle story. Step 3, simplify. Now, Leah, you asked, do we have to write all those x's out? Well, how many x's did I have to begin with?
4.
I had 5 to begin with. Now, how many pairs, you could just do this mentally. How many pairs would there be if I had 5 x's? So there's going to be 2 x's on the outside. And how many won't have a pair? 1, it'll be left inside. So you could just do that mentally if you want to. Just, yeah, you don't have to write out all the x's. So it's really not that hard to do that. Like, let's say I had this. Let's say I had x to the 19th. How many pairs would I have?
9.
How many would be left over?
1.
So you could do that if you want to. Totally cool. Yeah, what's up? Yeah, let me grab you a pass. I don't know if I have any more. Might have to let you go with that one. Yeah, I don't have one, so go ahead. I'll just have to cut them out later. Okay, so there's our story. So let's go ahead and hit up number 2 just as a secondary example. We have 16x to the 4th. Bonus point, just to see if you're listening. What's the number underneath the square root called? Raise your hand if you know. Yeah? It's called the radicand. Nice job. It's called the radicand. I don't really care if you know that per se, but it's a math word. All right, so I'm going to let you guys do this first. I want you guys to break this apart. Go ahead, take it down to its primes as far as you can go. Okay? I'll give you a second, and I'll ask you what you got.
Wait, what?
What did you get when you broke it down all the way? Like, what would I put in here, in other words?
2 times 2 times 2 times 2 times x.
Okay, now this is tedious, I know. I'll show you guys a shortcut, but not everybody can do the shortcut, like if you're not real good with your times tables and stuff, but I'll share a shortcut with you in a minute. But that is correct. Now, if you didn't get that, let me show you how to do that. So first of all, you ask yourself, what times what makes 16? 4 and 4, right? And 4 is 2 and 2. So you got 4 2s. So that's where our 4 2s are coming from. And then here we have our 4 x's. Okay, so we've got 4 2s and 4 x's there. Next, what I'd like you guys to do is I'd like you to do the turtle story. Have as many baby turtles as you can. Get rid of as many parents as you can. And then we'll see what you got. So go ahead. Okay. I did it right after you asked. Let me write it. Hold on a minute. Let me write it down again. Maybe it just needs to refresh or something. What was that about? We have a quiz every Tuesday. I can't remember. I think we had a quiz. Yes, we had a quiz last Tuesday. Lunchtime would be fine. All right, so let's see what you guys got here. Jedrick, what can we take out of there? How many things and what? We could take out 2 2s and 2 x's. Okay, so let's see why. I can take out a 2 for that pair, a 2 for that pair, an x for that pair, and an x for that pair. So we've got that. Now notice there's no more stuff underneath the square root. So when there's no more stuff on a square root, you just get rid of it. What that means is this is a perfect square root, okay? And we just multiply all this back together. What would that be? 2 times 2 is? And then x times x is x squared. So we got 4x squared is our answer. Now, I want to share with you guys another shortcut if you're ready for this. So, I'm going to share with you 2 things. But here we go. So first of all, I gave you guys a shortcut for this. How many pairs will there be? If you have 4 x's, how many pairs would you have? You would have 2. So I already know there's going to be x squared on the outside. How many leftovers will there be? There won't be any leftovers. So there's no x's on the inside. And here, we could just take the square root of 16. What is it? 4. So you could just jump to it like that if you know it. Here's another thing. Let me show you another shortcut here. Let's say I gave you guys this. Sometimes we can get some pretty big numbers. What do you guys know for sure would divide into 162? 2 would, because it's a what kind of number? It's an even number. So anytime you got an even number, it can be divided by 2. So You just get out your calculators, divide it by 2, and you can find out what the other one is. It would be 81. Now, that would be 9 times 9, right? Now, I could, you don't need to write this, but I'm just kind of giving you guys another example here. If I broke this down, this is what I would have. I could take out a 3, I could take out a 3, and I get this, okay? So there's that. But I want you guys to notice something. I didn't need to break down the 9s. Here's why. They're already a pair, aren't they? So if you have a pair already, even though you could break them down more, we could actually stop here and do this instead and save ourselves a little work. So if you see a pair earlier on, then you can kill that branch if you find one. But you can just keep going. It'll work either way. Here I kept going. I get the same answer. Here I'm using the shorter strategy, and you can get the right answer. But I don't have time to delve into 20 different strategies, but I just wanted to let you guys know some options. So if this is kind of like review for you and you want to find ways to go quicker, there are ways. So here's a couple for you. Go ahead and do 1 and 2 with your groups there, and then we'll see what you guys got. So there's our answers for 1 and 2. All right. So you guys ponder that for a second. There's a question on the board there. What do you guys think the answer to that is? What's the square root of negative 16?
Negative 4 and 4.
Okay, so I like what you said. So negative 4 and 4 does make 16, but there's a problem there, because a square root is asking what times itself makes that number. So I agree that 4 times negative 4 makes negative 16, but that doesn't work because I need something times itself, and 4 and negative 4 are not the same. So let's try again. What number times itself gives you negative 16? Negative 1 and 16? Those aren't the same, yeah, so that wouldn't work. Huh? Well, it has to be something times it has to be something times itself, so 8 and 2 are not the same number. Now let me ask you guys. If they're the same number, then they're either both positive or they're both negative, right? What do you get when you do a positive times a positive? You get a positive. So can my two possibilities be positive? Okay, so that means maybe negatives, right? What do you get when you do a negative times a negative? You get a positive again. So it seems like there's no way you can multiply something by itself to get a negative. But mathematicians came up with a new number to solve this problem. Okay? Now, why would they do that? I honestly don't know what was their initial reasoning for doing this. But I can say that it turns out that doing this is useful in some fields of electrical engineering theory, electromagnetic kind of stuff. But why they first came up with it, I don't think it was for that reason. I think it was just like a theory somebody had. But here's their theory. They came up with a new number called the imaginary number. And I want to re-emphasize to you guys, that doesn't mean that it's not a number. It's just a new kind of number, and they're calling it the imaginary number. Okay? This new imaginary number is what we call I. Stands for imaginary, right? And I is, we're going to say that's the square root of negative 1. Okay? Now, we can't think of any real numbers that have a square root of negative 1. And by real numbers, I'm talking about the numbers we're used to. Right? You can't find something that times itself would give you negative 1. Because it's impossible to have a number times itself give you a negative if you're using the numbers that we're used to using. Right? But, so that's why they had to create this new number called the imaginary number so we could do these kinds of things. Okay? Now this is also part of the definition. But we'll get to that part another day. But today I just want you guys to know this. So, but for our purposes today, we're going to use that new number to be able to solve square roots that otherwise we just have to say there's no answer. Have you guys ever wondered in a math book why it says no real solution or something? Have you ever heard that? Yeah. It doesn't just say no solution. Sometimes it says no real solution. Well, that means that there might be imaginary solutions. And once again, I don't like the choice of words because it's just another mathematical concept. It's not like fantasy or something. It was a weird choice of words they went with, but they did. So let's go ahead and take a look at number 1. Now, I'm going to do this showing you guys a longer way. It's really not that much longer, honestly. But from after that, I'm just going to show you how I usually do it. Okay? But here's what we're going to do. Negative 8x to the 4th. The first thing I want you guys to do is we're going to rewrite this like this. So, do you guys agree that negative 1 times 8 is negative 8? So I can just replace this with this. There's no reason why I can't do that. They're the same thing, right? But by doing that, I now have a square root of a negative 1. And what do we call that? That's an imaginary number. We use the letter I to represent it. So now what I'm going to do is I'm going to take that negative 1 and I'm going to change it into an I and just put it on the outside there like that. Okay? After that, you just solve it like you normally would. Now, I'm not going to show all my work for this. I'm just going to work it out kind of quick to get through the idea. But 8 is 2 times 2 times 2. And then we have 4 x's. I can take out a 2 x's, and I'd have a 2 left on the inside, and that's my answer.
Wouldn't it be 4 2 instead of 3? Or how'd you get 3 2?
2 times 2 is, well, I can show you. I don't want to get stuck on that because that's like the old stuff, but I can show you real quick if you're interested.
Oh.
Yeah. Because I know you guys are okay with that. It's just, I'm just going a little bit quick through that old stuff now. But there it is. Now, that's how we're going to handle square roots of negative numbers. Okay? Now, from now on, I'm going to skip this step here in the middle. I'm not going to do that. You guys don't need to cross it off on your paper. But all I'm going to do to solve these from now on is I'm just going to jump straight to this step by just crossing off the negative and putting an I out there. Okay? But that's what I'll do from now on. But I just wanted to show you the mathematical thinking behind it. We separate the negative from the 8 by making it a negative 1. And that is the definition of an imaginary number, so I write the I next to it. And then after that, since it's a normal square root now, we can just take the square root like we normally would. All right, so I'll do another example with you guys, and then we'll let you guys try some, and that'll be it. All right, so let's go ahead and write down number 2. So my first question, bonus point, if anyone wants to answer. How do I know this is an imaginary number? Someone raise their hand. Let me try it, Michelle. Because we're taking a square root of a negative. Good job, Michelle. Thank you. All right, so what I said I was going to do about that is we're just going to cross off the negative, and we're going to put an I out there. That's it. Okay? We're not going to do that middle step anymore. Now, let's go ahead and move on to our next step there. If I break apart 4x, what would that be? 2 times 2 times x. Good. And what can we take out of there? A 2. And there's my final answer. Okay? So, it's the same thing. It's just in the beginning, you cross off the negative and put an I on the outside. That's it. That's the process. The idea that's new is that we're dealing with a new type of number called imaginary numbers. Okay? Why do we have them? Well, like I told you, it's useful in some fields, so we're just exposing you to it, but it is a strange idea. Now, you guys might be offended at that, like, so we can just make up new numbers. Well, just so you guys know, whenever somebody introduced the idea of 0, people didn't like that either. When people introduced the idea of negative numbers, people didn't like that either. And when people introduced the idea of irrational numbers, like the square root of 2, they actually killed people over that. That was interesting. The Greeks took things very seriously. Yeah. So math is just ideas represented with symbols. So not a big deal. But there it is. So here's some practice for you guys. Let's see what you guys can pull off. All right, guys. So these are the answers here. But that's where we'll call it a day. Tomorrow we got our review test, so I'll see you guys then.